The half reaction method is based on the principle that electrons lost during the oxidation half reaction are equal to the electrons gained during the reduction half reaction. Let's look at an example. In this reaction, dichromate ions in aqueous acidic medium reacts with ferrous ions to give ferric and chromium 3 ions. Let's look at the steps involved. First, write the skeletal equation for the reaction in the ionic form. Then identify the species which have been oxidized and reduced, and split the reaction into 2 half reactions. This is step 2. In this case, the oxidation number of chromium decreases from +6 to +3. Thus, dichromate ion is reduced. Simultaneously, the oxidation number of iron increases from +2 to +3. Thus, iron is oxidized. Thus, the 2 half reactions can be written to show the oxidation half reaction and the reduction half reaction. In the third step, balance all atoms except oxygen and hydrogen. In this example, the oxidation half reaction is already balanced since the numbers of iron atoms are equal on either side of the equation. In the reduction half reaction, there are 2 chromium atoms on the left-hand side and only 1 on the right-hand side. So, we'll multiply Cr3 plus by 2 to get 2 chromium atoms on the right side too. Now in the fourth step, balance the H and O atoms. If the reaction takes place in an acidic medium, add H2O to balance O atoms and H plus to balance H atoms. If the reaction takes place in a basic medium, add H2O to balance oxygen atoms and OH minus ions to balance hydrogen atoms. In this case, in the oxidation half, there are neither oxygen nor hydrogen atoms. But in the reduction half, you can see that there are 7 oxygen atoms on the left-hand side, but no oxygen atom on the right-hand side. As the reaction occurs in acidic medium, to balance 7 oxygen atoms on left-hand side, we add 7 H2O molecules on the right-hand side. Now, after the addition of 7 water molecules, there are 14 hydrogen atoms on the right-hand side, but no hydrogen atom on the left-hand side. Hence, to balance the hydrogen atoms, we add 14 H plus ions on the left-hand side. In the fifth step, balance the charge by adding electrons to one side of the each half reaction. If required, make the number of electrons equal in the 2 half reactions by multiplying one or both half reactions by appropriate coefficients. The charge of iron on the right-hand side is +3, while on the left-hand side it is +2. Therefore, to balance the charge, we will add 1 electron to the right-hand side. In the reduction half reaction, there are net 12 positive charges on the left-hand side and only 6 positive charges on the right-hand side. Hence, to balance the charge, we add 6 electrons on the left-hand side. To balance the electrons lost in the oxidation half and gained in the reduction half, we multiply the oxidation half by 6. In the sixth step, Add the two half equations to obtain the overall reaction and cancel the electrons on each side. Thus, we obtain the net ionic equation as shown. Finally, verify the equation by ascertaining that the same type and same number of atoms and charges exist on both sides of the equation. Since the charges on both sides are equal, this is a balanced redox equation.